The line between 1 and 3 means this is the line between AC point, so that line ultimately cut to the saturated point. This temperature is called ADP of coil, because this is the line of AC. That means line between before AC and after AC, uh, and which is ultimately cut to the saturated point. This saturated point is called coil ADP, which is from our chart we already calculated measured in our chart. This is our 13 degree. 13 degree. Okay, this is 13 degree. Now I am erasing this. Okay, I am erase also this line, this point. Now this is room sensible heat point. Okay. Line between 2 4 4 means supply point, and TADP of room. This is called room sensible heat factor line, and line between 1 and 3 and TADP of coil. 1 and 3 is line the point between AC. 1 is before AC, 3 in after AC. This line is called gross sensible heat factor line. Okay, this is GSHF line, this is RSHF line. Okay, now erase this. Now erase this also. Now draw a line between two TADP of coil. This line is called effective sensible heat factor line, because effectively we want to maintain point 2, and TADP is the coil point, which is by which we conditioned our air, so that this is the point which is effectively work. 2 is the room point which we have to maintain, and this is our capacity of coil. This represents the capacity of the coil, or cooling capacity of the coil, because the coil temperature, if the coil temperature is very low, so that our cooling range is also very high. Okay, this is our point. Okay, now we go for we will calculate the remaining part of the point. Point 1 is done. Room sensible heat factor line is done. That is 0.714. Now point 2, condition of air entering to the auditorium. Condition number 2, the condition of air entering to the auditorium. That means this is 0.4, 0.4, 0.4, 0.4. Please tell the all of the data which is we have obtained from our chart, because the question is the condition of supply air, condition of air entering to the room. This is our calculation part. So first of all, 0.4 we know T4 is 23.4 degree. Similarly, we have also measured the 5.4 was similarly 72% or something. 5.4 and T omega 4 also calculated weight bulb temperature W4 weight bulb temperature. It is around 19.5 degree. Please check this value. 2 point is done. 1 and 2 is done. Now third part is amount of makeup air. Amount of makeup air. Suppose supply point is M4 makeup air. This is we have to calculate. First of all, room sensible heat. Room total sensible heat is the mass flow rate, mass supply to the room into enthalpy drop between room and before room. That means H2 minus H4. Okay, room sensible heat means 1,40,000 kilojoule per hour equals to, this is we have to calculate into enthalpy drop H2. Here or enthalpy line, how we calculate the H2 and H4. Okay, so H2 calculated, H2 is 61 minus H4 is 56. This is kilojoule per kg because it is calculated in terms of per kg. So mass flow rate equals to kilojoule is cancelled out, so that now we calculated 28,000. This kg is goes up kg per hour. This is our third point. Okay, this is our third answer. Now apparatus dew point. Fourth point is apparatus dew point, that is 13 degree, which we have already calculated through chart. Apparatus dew point. Now bypass factor. Now erase all this. Otherwise, figure is very. Oh, sorry. This not. Okay. There are there is two method. There are two methods to calculate the bypass factor. First of all, we calculate bypass factor through formula BPF. That means BPF means here this is BPF. So point 1 and 3, between 1 and 3, so that T3 after point minus TADP. ADP means coil, because bypass factor is represent the inefficiency of the coil. T3 before after point, after AC point minus coil point by before AC point by coil point. There how we calculate T3 is given. T3 is 23.4 minus T coil is 13 by T1 is given